Have you ever wondered how a stapler works? It's a small yet essential device that we use constantly in our lives, yet few know of the magic that lies within these sections of a stapler. There are three parts to a stapler. The front section has the thumb rest and the hammer. This hammer will push on the middle section, which contains the staples. The hammer will push out at the top of the first staple that's in this staples section. That will push it out and then go through the papers. And finally, there's the back section, which has these grooves used to make the shape at the back of the staple. But how does it work? For this, we need to cover some basic physics. Pressure is the intensity of force applied on something. The formula for pressure is force per unit area. As you increase force, the pressure increases. But as you increase the area that the force is exerted upon, you're spreading out the force more. So pressure decreases. Let's look at the real-world example of when you use a stapler. Most staplers have around a 1 square centimeter platform to push from your thumb. Generally, while stapling, you exert 10 newtons of force on the platform. This means that the pressure on the platform is 10 newtons per square centimeter. Because the hammer is physically connected to the platform, the force from your thumb goes straight to the tip of the hammer. But the tip of the hammer has a much smaller area than the thumb platform. The tip of the hammer has an area of 0.1 square centimeters, meaning the pressure at the tip of the hammer is 10 newtons per 0.1 square centimeter, or 100 newtons per square centimeter. This means that the pressure has increased tenfold since you push here with the thumb and the area has decreased by 10 times. Next, the hammer hits the top staple in the staples section, transferring all of the force that it once had to the tips of the staple that was going to be going through the paper. Now that the force is concentrated in these tips of the staple, which have a total area of 0.0002 square centimeters, the pressure is now 10 newtons per 0.002 centimeters, which comes out to 50,000 newtons per square centimeter. To put that into perspective, each car weighs around 10,000 newtons. And one fingertip is around 1 square centimeter. So the pressure at the ends of these staples, just as it's about to enter the paper, is the same pressure as if you were holding up 5 cars with the tip of your finger. The pressure concentrated at these two tips of the staple allows it to burrow through the many sheets of paper that you'll be stapling with the stapler. It's like using a hammer and a nail. If I use this big cup, it won't go through the table because there's not enough pressure at the tip of the cup. But if I use the nail, there's enough change in the surface area that allows for a very high pressure at the tip of the nail. So if I hammer it in, the nail will go inside the wood. But then what's the purpose of the back part of the stapler? I've seen many of my friends make a mistake, and that's doing this. This doesn't work and results in a broken stapler and unstapled sheets. Really, what you need to do is put it in between the sheets, like this. What the back part of the stapler does is it has these grooves here. And what these grooves do is they take the ends, the tips of the staple, after they pass through the final sheet, and these grooves bend these tips together. And what this does is it locks the staple in place, like this, having this shape. See how the staples are bent together? If they weren't bent together like this, the staple could fall out of the paper. So in summary, the main principle of a stapler is that the pressure goes from 10 newtons per centimeter square at the thumb platform to 100 newtons per centimeter square at the hammer to 50,000 newtons per centimeter square at the edges of the staple. This extreme pressure is what allows the staple to burrow through the many sheets of paper that you'll be stapling.